So MGU-K stands for Motor Generator Unit Kinetic, and it's a component of the hybrid system in hybrid engines in Formula One car and hybrid cars, which helps the car in slowing down quickly and helps in acceleration of the car. So it has two components: generator mode and motor mode. When it acts as a generator, it is converting kinetic energy into electrical energy. So instead of being losing that kinetic energy during breaking into heat energy, this component of MGU-K converts it into electrical energy, which could be used later during acceleration, when it will act as a motor mode, when it will convert that stored electrical energy into kinetic energy, and hence increasing the speed of the car, faster acceleration. So the components involved in this whole system are mainly three: the MGU-K, which is attached to the crankshaft and which is attached to the tire from one end, and the other end is attached to the battery. This is just a simplistic diagram to make you understand. So when the car slows down, what's actually happening here is that kinetic energy, since when the car is slowing down, tires are rotating at a less speed, and this kinetic energy, instead of being lost as heat, is being converted into electrical energy via the MGU-K and being stored in the battery. So the kinetic energy levels decreases and electrical energy increases and being stored in the battery. So this is called energy recovery or braking phase or generator mode. Now, when the car accelerates or when the car needs more energy, the stored electrical energy is converted to kinetic energy for more power, for more efficiency, and this would be again done by MGU-K, which will convert that stored electrical energy into kinetic energy, and this is called energy deployment phase or acceleration phase or the motor mode when MGU-K is acting as a motor. So how's all this happening? So if we zoom in into MGU-K, it's mainly made up of two things. It's the coils. So the crankshaft is actually attached to the coils. So when the wheels start accelerating slowly, even the coils will start rotating slowly, and hence there is a change in motion. There is an acceleration, and these coils are being surrounded by magnets, and magnets in between them have magnetic field. When these coils cut the magnetic field, it will induce a current, and the direction of all the current induced, can be given by Fleming's right hand rule. Now that's how change in motion induces current, and this current flows into the battery and being stored as electrical energy. Now during acceleration, the opposite happens. Stored electrical energy in the battery, so the current will move from battery to the MGU-K through the coils, and when it does so, there will be a force which would be generated, and that force will help the wheels to rotate quickly and hence the electrical energy will be converted to kinetic energy. Now it looks simple, but the thing is, the motion we needs to be rotatory, because it's a wheel and we need it to move forward. So there are uh, there are different arrangements which we do in our system. For example, using a coil instead of a wire, and how we use an AC current, alternative current, instead of a DC, because it will switch its direction, and hence the total arrangement needs to be set up in such a way that the direction of coil, the current, and the magnet helps in rotation of the wheel, either increasing the rotation or decreasing the rotation. And that's how you can modify the MGU-K. You can also improve its power by depending on how many coils you use in MGU-K or how many magnets it is surrounded by. Cutting more magnetic fields or more electrical strength will mean generating more power, either electrical or kinetic, and hence increasing the braking efficiency and the power deployment. That's it.